you flip a switch on the wall. Across the room, a light turns on. Not after a delay. Instantly. You've done it 10,000 times without a thought. But something just traveled from your finger to that bulb, faster than you could blink. So here's a simple question that turns out to have a very strange answer. What actually moved? Most of us carry the same mental image. Electricity is a stream of tiny particles, electrons, rushing through the wire like water through a pipe. You open the tap, the water races to the other end, the light comes on. It's a clean, simple picture. It's also wrong. Here's the part almost no one is told. The electrons inside that wire are barely moving. In a normal household wire, they drift along slower than a walking ant, a few millimeters per minute. At that speed, a single electron leaving your switch wouldn't reach the bulb for hours, and yet the light came on the instant you flipped it. So if it isn't the electrons racing down the wire, what is? To answer that, forget the pipe. Picture instead a tube already packed, end to end, with marbles. Push one marble in at your end, and a marble pops out the far end almost immediately. Not because your marble traveled the whole way, but because the push passed through all of them at once. A wire is already full of electrons. Flip the switch, and you don't send electrons on a journey. You send a push, and that push is not really in the wire at all. When current flows, it creates an invisible electromagnetic field in the space around the wire. That field is where the energy actually lives. It spreads out from your power source at nearly the speed of light, fills the space around every cable in the circuit, and delivers its energy into the bulb from the outside in. The wire isn't a pipe carrying the energy. It's more like a rail, guiding a wave that travels beside it. Now the words on your appliances make sense. Voltage is the pressure, how hard the field pushes. Current is the flow, how many electrons jiggle in response. Resistance is anything that fights that flow, and in doing so, turns the energy into heat or light. A bulb glows because its thin filament resists the push so fiercely that it heats until it shines. The light in your room is, quite literally, a wire struggling against the field. So sit with what that means. The power that runs your home didn't come through the wires like water down a hose. It rode an invisible field through the empty space around them, at almost the speed of light, while the electrons inside barely shuffled. Everything electric you have ever used, every screen, every light, every machine, runs on a force you cannot see, moving in the space you thought was empty. And here's the humbling part. We are extraordinarily good at using this. We've wired the planet with it, built civilization on it. But ask a physicist what the electromagnetic field fundamentally is, not what it does, what it is. And the honest answer gets very quiet. We lit up the world with something we command perfectly and understand only to the edge. So flip the switch again. Watch the light obey. There's an invisible ocean filling the room, and you just sent a wave across it. For more of the things you thought you understood, subscribe to Wait What?